Peter actually left it at a very good note about cloud native and the adoption of containers. So I'll take it from there. So let's start with this. Cloud native generally, there's a lot of talk about it at this conference, and I wanted to start with this on whether it's worth the hype. So a lot of organizations have their own ways of determining this. Some of you would look at maybe the Gartner hype cycle to decide whether a technology is worth adopting or not. Some of you would probably look at some of the monikers like the web application providers, etc., on how they're adopting this. And some organizations do their own research to do this. For me, actually, there's a very simple moniker to decide whether a technology is worth it or not, and that is actually Dilbert. If a technology shows up in a Dilbert cartoon, then it's definitely worth the hype. So Dilbert is talking about cloud native, so it must be important. So let's dive into it and talk about what really it is. Okay, so the essentials of cloud native. There's actually 4 parts to this, and the first half of this is about essentially microservices and containers. How do you take your existing monolithic applications, break them up into microservices? Why is that important? Because it, first of all, lets people focus on specific smaller parts of the application and make them better. The other part is that you can use containers to make these applications much more lightweight and easy to scale in and scale out. And eventually, this becomes a very important part of how applications get built inside the cloud. So that's one part of the equation. And the other part is about automation and adopting the whole CI/CD pipelines. So how do you deploy these networks using DevOps? How do you use agile methodologies? How do you build continuous integration and development into them so that as your applications are built, they're automatically tested, they go into some form of limited trial and then into production. And if you look at each of these different aspects, each of these could easily be worth a session of their own. What I want to focus on specifically is this piece around microservices and how it's impacting networking inside the data centers. So the idea is from a logical perspective, it's quite straightforward. You want to take your monolithic applications and break them down into smaller pieces, which are these microservices. So what happens from there is that all of these interactions that were happening inside this monolithic application that were invisible to the network, suddenly when you break this out and you make it loosely coupled, they are now visible to the network. And from a logical perspective, it would probably look something like this. The traffic comes in. At some point, it goes into, let's say, your front end, goes into some kind of middle tier, and then into the database, etc. So, and just within each part of the of this application, there are so many more transactions now that are visible to the network that were previously all inside this monolithic application. So if you compare what we had previously to this, actually it doesn't look too bad. Because there's a few more connections, but SDN is made for things like this. It can surely manage this. But this is just the logical architecture. The actual architecture looks something like this. So this is actually how these applications, these microservices get deployed. And the word that gets used for this is a microservices Death Star. And if you've been following this ecosystem or this topic, you would see similar Death Stars from Netflix or Twitter and all of them. Once they start deploying microservices, the amount of interactions that are happening inside the network, it's just phenomenally very high. So the problem with this is that the application complexity becomes very high, because now this little application that I have broken out of the monolith is responsible for making sure that it can talk to all the other parts of the other little applications that exist. So if there is latency in accessing that little small part of the other application, this application needs to handle it. If there is some kind of a failure that happens, the application needs to know how to recover from it. So the network, from some perspectives, can help. But now there is a much more complicated problem that we need to solve of how all of these different interactions happen. How do you manage security? How do you make sure that it doesn't fail? And how do you, for example, just handle the scale of this thing? I mean, the whole intent of this cloud native architecture is to be able to move faster. But if you look at this kind of complexity, it might have the reverse effect of actually slowing you down. So how do you ensure that that doesn't happen? So let's firstly look at how such an application would get built. So if you were building, for example, some microservices, some application. So the traditional way of building that microservice is to say, okay, I have some business logic, and then I will have the network stack, which always exists. So this network stack could be your SDN, you could call it maybe something like TCP/IP. It doesn't matter. But the network stack has a role, and that remains. But now, because of microservices, this application needs to do a lot more. It needs to do things like discovery of services. How many containers do I have for this other application that I need to talk to, or this other part of the application that I need to talk to? Are all of those containers up, or how many of them are up? How do I know whether the service exists or doesn't exist? So I need some form of service discovery. I need to be able to take care of security when I'm talking to these microservices. I need to be able to do canary deployments. I'll get to that. And then also collect telemetry for all of these things. Right? So this now become the application developer's responsibility, not just to work on the business logic, but also to do a lot of other things which, previously they were not so worried about. They just relied on the network, which was kind of oblivious to them, and the network just delivered the connectivity that they required. But the applications with microservices become much more complicated. So what's the better way to do this? The better way to do this is to use something called service meshes, which is what is becoming quite prevalent recently. Service meshes is a relatively new term. I think it started about gaining traction about 2016, 17. There's a few options that are available. But essentially, the idea is that just like the network used to be a part that the application always just assumed was available, why don't we make all of these other services also just like a sidecar that can attach to that service and just become available, so that the application developers don't have to worry about it. There's someone else who takes care of all of these pieces. So in some ways, the service mesh is becoming the new TCP/IP. So you never thought when an application developer is building an application, he never thinks about what are the flow control mechanisms that will happen if there is congestion in the network. TCP takes care of that. So somebody needs to take care of these other pieces, which are service discovery, inbuilt security, taking care of latency and failures and things like that. So that is service mesh. And what I want to focus on is this part of service mesh and how it's changing the way networking is being done inside these cloud native environments, and how that plays from the context of things like SDN and all that we talk about a lot. Okay, so we've broken this up into a sidecar, and your microservices architecture would now start looking something like this. So instead of having a lot of microservices where the service takes care of everything, you just build the service. You don't worry about the sidecar. The sidecar gets attached to every service that gets built automatically. And this sidecar, by default, provides all of these connectivities in terms of how all of these functionalities need to be provided. So who is doing this? Service meshes are actually, there's a few options that you have in the industry today. A few of them, which are quite popular, are technologies like Istio, Console, Linkerd, etc. These are all, based on, they are either open source or based on open source technologies that are being adopted into, of course, commercial products as well, but are being adopted directly by either enterprises or clouds or service providers also. So, what does a service mesh actually provide? So, there's some basic functionality that the network is already providing. We don't want the service mesh to be doing the same job. It has to do something that is very relevant to microservices and that is not available outside the scope of, not available with networks, etc. So what is that? So first thing is service discovery. With all of these, like I mentioned, all of these containers and microservices coming up, if you've got hundreds of thousands of such containers, you have to always know what resources are available inside the network so that I can either bring them up or bring them down, or I know who I can connect to. let's say if a request comes in and I need to forward it to, let's say, a web application, I need to know how many of those containers are available, are they up or not, what percentage of them are having some kind of a failure, etc. First thing is you need service discovery. So service meshes bring in this concept of service discovery, so that everybody, as soon as they come in, they announce themselves to the service discovery, and the service A, if it needs to route the packets into service B, it just needs to refer to that service discovery to know where to go next. The second part is security. Security gets inherently inbuilt. There is a control plane that ensures that when two services are talking to each other, two microservices, there is inbuilt security with TLS certificates, etc. Third part is canary deployments. If you've heard presentations from Netflix, you would have heard about this concept of okay, I've got this application that that is in production today. I'm adding this new feature to the application, and I want to test a small percentage of my users with this application. So that's essentially canary deployments. So 95% of my traffic continues to go into the production environment as it is. 5% goes to this new deployment that I have done. And canary deployments are actually also inbuilt inherently into service meshes. So you don't need to build application logic to do it. You just need to use service meshes to help you do that. And the last big one is around telemetry. So as all this traffic passes through the different microservices, I just want to keep collecting all the data so that I know what's going on, and then I can take action based on that. There's other stuff that microservices can do. In the interest of time, I'm going to skip, but essentially all of these are very important pieces, like how do I load balance across different services? How do I do things like circuit breaking if my applications are backing up, if my service is backing up and it cannot take any more traffic, I should stop sending traffic to it. I should break the circuit so that I no longer keep sending traffic to it, so that it doesn't break the entire application. Similarly, things like if there is latency, how do I ensure that I can reroute to another application which is less latent, retries, deadlines, and things like that. So this is the value that the service mesh is bringing. And the big question that comes up when in the context of service meshes is that how do they fit in with all of this ecosystem of SDN that we've been talking about? Is service mesh a replacement for the existing SDN? Is it complementary? How does this work? So this is actually an architecture of one of these service meshes, which is Istio. And what you see here is the service at the bottom. The sidecar that I mentioned previously, which is attached to it, is blue. The sidecar in this case is called Envoy. And then you've got, so that is the data plane. And then you've got a control plane that's managing all of this, which is the Istio control plane. And actually, if you look at that and compare it with something like an SDN controller, which does container as a service, and here I take the example of Tungsten Fabric, which is Juniper's open source solution for container as a service, and commercially sold as Contrail. You see that they are very similar in the way they look. They're kind of doing things that seem to be very similar. You've got a forwarding plane layer which is doing all the routing between the containers. You've got a control plane layer which is taking all the telemetry and things like that. So is service mesh the next generation SDN? So from the perspective of the cloud providers, in some ways the answer is yes. However, service meshes, while they have added a lot of critical functionality that SDNs do not provide, they still have some gaps, specifically from the perspective of service provider environments. So those missing pieces are essentially around how service meshes ingest traffic that comes into the ingress. There's no good solution available today to do that. SDN already has an inherent established mechanism to do that. The second part is that since it comes from an application mentality, the whole concept of service meshes, and it's meant to be that way, it's focused around layer 7. So it takes care of all of this traffic that's coming in on HTTP, HTTPS, HTTP2, and it does all of these good things with it. But layer 7 is not the only traffic that runs inside the network. You've got layer 3, layer 4, layer 2. And while service meshes make the communications of first-class citizen from the perspective of layer 7, SDN has already been doing that from the perspective of layer 2, layer 3, layer 4. So there's still, if you've got, let's say, for example, RTP traffic for your voice and things like that, that also still needs to get all of the attention that it needs. Other things like NFV optimization, for example, how do you manage high-performance workloads? How do you take care of workloads that require multiple interfaces into the network? All of that stuff, service meshes still have a gap. And then there's other stuff, right? Your microservices, service meshes are focused on microservices, but traditionally in all your deployments, it's not just microservices that are getting deployed. It's always a mixture of the VMs, the bare metals, the containers, all of that. So you need something that kind of cuts across all of these. And last but not the least, service meshes have been around for a while, but they're still maturing. SDN from that perspective has seen much more runtime in production environments, etc. So that actually leads me to the next point, which is how do telcos adopt this? So if you think from the perspective of telcos, these requirements of service function chaining, data plane acceleration, making sure that you are aware of the environment that you fit into, whether you're in a centralized cloud or a distributed edge or inside a POP or in a data center, bringing that visibility in, and then doing multi-site deployment. These are all things which are very important, relevant from a telco perspective, and there's still some gaps from a service mesh perspective to address these. So the way to look at service meshes and SDN from where they stand today is that they work better together. As service meshes bring in a lot of functionality that doesn't exist in SDNs today. But SDNs have been proven inside networks, and they've been kind of optimized for certain kind of environments that exist in production today. So if you think about an SDN controller, this is actually the view of Juniper's Contrail solution, which is open sourced as Tungsten Fabric, which not just takes care of containers but also does virtual machines, bare metals, public clouds, etc. So a single SDN controller that goes across all of these. And like I mentioned previously, there are requirements in terms of optimization of the NFV workloads. So whether you need to use DPDK-based acceleration or SRIOV-based acceleration, or you want to use SmartNICs inside your network to optimize your user plane workloads, all of that, SDN already has an ecosystem to provide that. So the message essentially is that service meshes from a cloud-native deployment perspective are a very important technology that should be looked at because of the value that they bring from a microservices perspective, and they have to go hand in hand with SDN based on the value that SDN provides today. Okay. So one last thing that I would want to mention is that how it makes sense for service providers to consider adoption of microservices. Like my previous speaker said, a conference like this wouldn't be complete without a slide on 5G. But actually, 5G actually makes a very nice sweet spot for adoption of microservices inside the service provider infrastructure and adopting cloud native. Actually, the prediction is that these Kubernetes-based deployments for cloud-native applications are first going to show up in the distributed clouds that service providers are building, rather than in the centralized clouds that already exist today, which are predominantly based on OpenStack, etc. So as you're building these, if you look at the RAN side, on the RAN side, we have the mobile core, we've got the multi-access edge computing, and then the radio paths that's been broken up into the CU and the DU. So the centralized unit, the distributed unit, the MEC, the mobile core, they're all kind of broken up into services, and it makes a lot of sense to build these using this microservice architecture. And if you look at the core again has already been kind of broken up into these functional service groups, so based on the 5G service-based architecture. Whether it is the UPF functions, the PCF, the SMF functions, etc. All of these are ripe for adoption of microservices using the 5G service-based architecture. So that, I think is a way to look at adopting microservices into a telco environment. And as you do that, you start to think about how to build cloud-native networks. And that's where the concept of service meshes will play an important role on how you build them, coupled together with SDN the way it exists. So that's kind of a wrap of what I wanted to talk about, from the perspective of building cloud-native networks. 4 key things. Cloud-native networks is a combination of containers, microservices, CI/CD, and DevOps. Service meshes help you decouple this idea of business and infrastructure logic. Service meshes and SDN based on today's problems set, they work very well together. And 5G actually provides a very good, breeding ground for adoption of these microservices and service mesh-based architectures. And that's it. That's a wrap on the session, and hope you all enjoy lunch. Thank you.